In the beginning, there was darkness, and then bang, giving birth to an endless expanding existence of time, space, and matter. Every day, new discoveries are unlocking the mysterious, the mind-blowing, the deadly secrets of a place we call the universe. As they try to unravel the mysteries of the universe, scientists are coming to an astounding conclusion. To make sense of outer space, they need to understand inner space, the microscopic matter that forms the foundation of everything we see. But shrinking down billions of times into the realm of atoms and subatomic particles takes us into a strange, unexplored world.
When we descend into the microscopic world, we find that it's really weird, and indeed downright bizarre and unbelievable.
The stuff in this universe is far smaller than anything we can see with a microscope, but it holds the key to the cosmos.
We can only understand where we came from if we understand this crazy micro world.
So let's go on a fantastic voyage into an uncharted world known as the Microscopic Universe. When people talk about the universe, they usually mean the vast expanse of space, billions of light years across, that they can see with radio telescopes and cosmic imaging.
They think about stars and galaxies and planets and all the big stuff out there.
You have astronomical bodies moving under the force of gravity.
There are laws of nature, and you think that the laws are right once and for all.
However, there is another universe, an unseen world that governs everything we see.
When we go down in size, trillions of times smaller, to the microscopic world, the rules are much less intuitive than the ones we're used to from the large-scale world.
The magic of the microscopic universe begins at about a 10/1000th of a meter, or the size of an atom. Matter behaves so differently at this level that scientists have developed an entirely new set of rules to describe what's going on. They call it quantum theory, and what it says is extraordinary.
This baseball represents a subatomic particle, like an electron or a photon of light, that routinely does all sorts of weird, strange things in the microscopic universe. The subatomic version of this baseball can be invisible, can go through solid objects with ease, can be in multiple places at the same time, and can seemingly go backwards in time and change the past. This means I could throw this microscopic baseball to first base and to home plate at the same time, or change the seemingly predetermined outcome of a play while it's still going on. Now, this is the stuff of science fiction, but really, we know it to be true, or at least it appears to be true in our quantum world. We get all sorts of weird things happening.
If scientists can understand how these weird things work, they'll be able to put them to use in our everyday world, revolutionizing modern computing and perhaps even allowing us to communicate across the cosmos instantly. The key to making these miracles come true is a process called quantum entanglement, and scientists are already harnessing this astounding discovery for both civilian and military purposes.
In quantum physics, what happens to an object over here can instantly affect an object over here, and over here could be millions of miles away.
This is how it works. When two subatomic particles interact, they can become entangled. That means their spin, position, or other properties become linked through a process unknown to modern science.
If you then make a measurement of one of the particles, then that instantaneously determines what the behavior of the other particle should be. And when the experiment is done, it's found that indeed the other particle's quantum state is exactly determined once you've made a measurement of the partner particle's quantum state.
That means if a scientist observes one entangled particle and forces it to spin clockwise, the other entangled particle will immediately start spinning in the opposite direction. That seems intriguing, but it's hardly earth-shattering until you consider that the two entangled particles can be separated by billions of light years. And still, the moment you observe one particle spin, you've dictated the other particle's spin.
That's weird because it may suggest that information has traveled instantaneously, faster than the speed of light, from one particle to another. I don't understand it. I don't know that anyone does. Spooky action at a distance, as Einstein called it.
Quantum entanglement is more than a curiosity of the microscopic world, because the effects of entangled particles can be seen and felt in our world. If scientists can overcome some fundamental obstacles, quantum entanglement could someday help humans communicate across vast distances instantly.
People sometimes think that quantum entanglement will achieve the desired goal of transferring information at a speed faster than that of light. I don't think this will be achieved because to set up these systems, you had to have brought them there at speeds slower than the speed of light. But then what do I know? 100 years ago, they didn't think that we'd be going to the moon.
Quantum entanglement is far more likely to transform modern computing. Scientists hope to use the magic of the microscopic universe to build powerful new computers.
We're going to see what this baby can do.
At the Massachusetts Institute of Technology, Professor Seth Lloyd has helped create a prototype of a quantum computer which uses quantum bits rather than traditional computer bits to perform its calculations.
This lab has the world's best superconducting quantum bit, or qubit, in it. And when we do quantum computations with qubits, we can have the quantum computer do multiple tasks simultaneously. It can do this, it can do that at the same time. It can add 2 plus 2, it can add 1 plus 3, and it can add those two things simultaneously.
The fact that a single qubit can perform many calculations at the same time gives the quantum computer the potential to be far more powerful than any computer ever imagined. Like traditional computers in the 1950s, quantum computers are in their infancy today. The machines take up large rooms and can do only the most basic calculations. But they hold great promise for the future.
Quantum physics is notoriously weird, strange, and counterintuitive. And so quantum computers use this weirdness to compute in ways that classical computers can't.
The major stumbling block is figuring out how to effectively code classical information, the ones and zeros that computers use, in a way the microscopic universe can process it using entangled particles. But when scientists figure that out, quantum computers could transform the planet.
Even if you have a quantum computer with not that very many bits, you might still be able to do things like break all the codes that people use to communicate on the internet. Or you could solve very difficult problems having gajillions of variables, like try to figure out what happened at the Big Bang.
That may be hard to believe, but the microscopic universe gets even stranger. In fact, the most famous experiment in quantum physics shows how one object can be in two places at the same time. a result that startled the great Albert Einstein.